Hello everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own after some trial and error, so I'm really happy about this. I was kind of surprised I was able to solve it on my own. I thought it would still get time limit exceeded, but I managed to do it. So again, let's go over it. I'll show you my own solution again. It's a little messy, but it works. So basically, you want to follow these instructions here. You want to define an object with size n, and then you want to find the leftmost block of size and allocate it with MID. Basically find like current plus size. If it doesn't go out of bounds to the right of the array, then set it to MID and then return that first index, otherwise return -1, and then do the same thing, turn them back into your original value. So let's go ahead and define an array. Let's fill the value as -1 because you notice here that the smallest n and MID could be, they have to be positive. They have to be bigger than 0, right? So -1 is the value it's not going to have. And so now what that's going to allow us to do is later you'll see you can get the subarray sum and evaluate some things. So basically now let's call this self.size as n. And then to allocate, let me show you my initial solution and then what I came up with to get overtime limit exceeded. But basically, find the leftmost block of size. So basically for I in range, everything to length of self.current. Let's call this, well, that's just going to be self.size because it's of length n. And then if self.current of I is equal to -1, that means we need to change it to MID, and that's also a possible answer. So in that case, if the length of set of, well, first, if I plus size is less than self.current, that means we're not going to go out of bounds to the right? If we have this and we want to get 3 more, you can't because you're going out of bounds, versus you only have so much, you can go to the right. So if that's the case, then we can actually allocate this block of size, and it's probably not good to call it size. Let's call this width, or whatever you want to call it, self.w. And if it's less, then we can basically ask if we can allocate it, which means that it has to be, everything has to be -1 in that particular subarray to allocate it. Otherwise, we cannot do that because it has to be consecutive free memory units, right? So basically now, if length of set of self.cur I plus size is equal to 1, this is what I originally did, and self.cur of I is equal to -1, that means everything is -1. And we're going to optimize this in a second, but just to show you, for j in range I to I plus size, we want to allocate this specific block that's valid. So self.cur of j is equal to MID. And let's call this now because we're actually going to append this, which is a leftmost block. We want to return that index. And then at the end, once we finish this, if now is not empty, then return the first index, the leftmost block. Otherwise, then return 0 because there was no block. And then at the end, you can just return -1. To free the memory, it's pretty easy. For I in range, length, range self.w, if self.current of I is equal to MID, then set it back to -1, which is our default value, right? And then at the end, you can just return result, which is just going to count how many MIDs we have and how many we had to reset. So this technically works, but it's going to be too slow, or there's some edge cases as well. So else return -1. Nope. Okay. Is it return -1? Turn 0. Instructions can be a bit unclear as well. set it to this. I plus size is less than length of self.w, or just self.w. Let's do this. Self.w is n. Minus size plus 1, because if we have this boundary check, we already know that it can't be bigger than this. So that saves a tiny bit of time, but let's do length self.current. Is it -1 here? Nope. Okay. Return the number of memory units you have freed. Okay. I equals to -1. I plus size is less than or equal to, maybe. That was the edge case. There we go. So again, this technically works, maybe just one-off errors, but it's too slow because this is n, and that's a hassle. So what we're going to do, as you see, you get time limit exceeded, what we're going to do is we're going to create, I'm going to use a nice trick here. Basically, we want to get the sum of this. How do we make sure the sum of everything is -1? Well, the sum of this should equal to the negative of the length. So the sum of this should be -3. The sum of this should be -4, right? So first of all, we can get a prefix sum. So b equals list iter tools dot accumulate self dot current, and then we can quickly get the subarray sum that we need of this. So basically, if sum of self dot cur I plus size is equal to -1 times the size, which is the length of the subarray, that substitutes, it basically does the same thing. But we want to do this quickly, and we don't want to have to do this. So what we're going to do instead is, first of all, we want to update everything to MID. So if that's true, instead of this loop, why don't we just say self.cur of I to I plus size is equal to a subarray of MID times size, and now dot append I, because that's already the first block if there is one, right? So that already gets rid of this loop, which is good, because we want the leftmost block, which is going to be I if there is one, meaning the array is not empty. And then this becomes the bottleneck now. So how do we get the sum quickly? Well, if, again, with prefix sums, if we're looking at everything to the left, if I is less than or equal to 0, the left bounds, then the subarray sum is just going to be b of I plus size minus 1, which is, if we want to get the subarray sum here, it's just the prefix sum of this minus everything before. So otherwise, the subarray sum is equal to b of I plus size minus 1 minus b of I minus 1. And then if the subarray sum is equal to this, then that should work out. And there you go. So really happy about this. I was able to come up with this and get over time limit exceeded. I think this might be n. Again, the runtime is not the best, but again, I did come up with this on my own after a lot of struggling. So pretty happy. And yeah, that's it for this video. Thank you for watching, and stay tuned for more.